I wanted a quick prototyping method for building maker projects or data science projects. I came across this library called Streamlit. It's an amazing library. You can write a few lines of code, you can write a web page with interaction where the user can select boxes, click on things, and it can display data from Python data science libraries. It just makes it so easy. Mixing this with the Raspberry Pi and the Raspberry Pi little touchscreens is just perfect for it, just little maker projects. There's so much you can do with this, and I'm also using the Raspberry Pi HQ high quality camera, so I'll get on and show you the hardware, and then we'll dip into the code, the library, and how it all interacts together. Right, the first thing to show you is the camera from Raspberry Pi. This is the camera here, and I've just got a little tripod, and I've also got a lens on there as well. So the first thing to do would be to show you the actual camera. So you just screw the lens, and you can see the Raspberry Pi camera there. So you just scroll to the back of it, or twist it to the back, you can actually see the circuit there. So all it is just a sensor. It's like, I think they say it's like a CCTV sensor. So it is a good quality sensor. I've got some really good photos from it. You can get quite a few different lenses. Pimoroni Spy 2. So there's the lens I've got here, and there's also a wide angle lens. This can go or focus in on objects far away. So just screw that back on. And what you get on this one is you get an aperture, so that's how much light goes in. So I believe the lower the number, the better quality picture you'll get in low light environments, and the higher is better for the opposite. What we've got here is the actual focus as well. So you can focus in and out depending on where the object is. And the next bit is the screen here and the Raspberry Pi. So this one has got, it's quite an old Raspberry Pi screen. I think I got it 3 or 4 years ago, but it's just something I had in the cupboard. And it's touchscreen, and it connects to the Raspberry Pi just through the GPIO. And it also connects through the HDMI to the Raspberry Pi. So this is Raspberry Pi 4 I've got. It's also got power, so just a 5-volt power using USB to the screen, and a 5-volt power to the actual Raspberry Pi. And that is it. So I'm just going to pop that down. This is the Streamlit demo GitHub repository I created. The idea behind this is that you can just follow through and you can get to where I got to. So to start off with the overview, which I've already gone through, why I've done it to help prototype some of the things, maker projects that I've done, and data science projects. And I've created 3 scripts. The first one is First App API, which is just some data science type objects. It's got some pandas in there, and it shows you how to display it, just randomly thrown on there. And then I've got one which is a text picture, and it saves the picture to the SD card on the Raspberry Pi. And then I've got the OpenTV video detection. So that one's using OpenTV as well. This one's using OpenTV, but it's doing a video, and it puts a box around people's faces. And then I've just created some links of where I've got the inspiration from. The thing that I had a problem with using Streamlit on the 32-bit, it just can't be done as of this recording. But I followed some instructions on the Streamlit, and I've used the 64-bit version of Raspberry Pi, which is still in beta. But I've looked around, and everyone says it's working, and it's working fine. And I've used it successfully, so all's good. So that's where you get the image from. And then these are the commands you need to install Anaconda and Streamlit. Heroku is something that I've not implemented just yet, but it's used a lot in computer vision and also robotics. So this is the touchscreen that I've used, and then this is how you set it up. So these are the commands that you put in, and then the things that I want to do in the future is an Heroku Streamlit app and a Docker installation. And then this is just further information that I need for myself or for anyone else who wants to actually do this. What we're seeing here is the information that was on the GitHub page. I've just opened one of the files, so I've opened my first app. What we've got is import Streamlit, so that's imports in the library that I want to test out. NumPy, which is a library for data science, and pandas is the same data science library. That's creating a title and print it and writing it to screen. This isn't writing anything to screen. All it's doing is creating a data frame, which you can kind of think of as an Excel document, or the spreadsheet type document, if you've never done any data science before. And then what we're doing is we're printing that data frame, so that DF, to screen there. STWrite just means it's going to write. So Streamlit's going to write to the screen, and then we're going to write the data frame listed like that. So the next one we're going to do is we're going to create a chart. So we're creating a data frame, and we're creating a random numbers. So NumPy, creating a random, and I don't know what's actually in between the parameters here. See whether it tells us now. No, it's not going to tell us. Okay, so it's going to create something there, and then it's going to display it on screen. It's going to be 3 columns in there. And then this is actually doing it in a line chart style. So ST, which is there. Streamlit is going to create the line chart, and then we're going to draw another map. So another a NumPy function that's going to create it might be an array of 1,000 rows but 2 columns. Not sure about looking it up, but you'll get the idea when we look at the app. And then we're going to display the map just using the st function map. We're going to stick a checkbox on there. We're going to show data from a data frame again. What else we're going to do? We're going to import time, but is time actually used anywhere? Oh yeah, we've got sleep there. We've got latest iteration. We're just going to stick on a progress bar, and then we're going to counter the progress bar. We're going to sleep during the progress bar. Okay, so that's done. So to run this, all you need to do is commit to the command prompt. So at the moment, this is connected to the Raspberry Pi, and the IP address is that. So what I'm going to do is I'm going to run the Streamlit hello, and then I'll show you what actually happens on the screen, on the little Raspberry Pi screen. So this is going to load up, and all it's doing is showing a web page. So whichever machine you're connected to on the network, you can just open up the link using that link there. But I programmed the Raspberry Pi to sort of view that within the Chrome browser. Okay, so what we have here is the My First app, and if you see, we've got the sort of data frame that we created earlier. So it was like a spreadsheet. So we've got that in twice because we had the code in twice. And then we've got the chart, and then we've got the map. You can actually scroll around the map as well. So that's it. That's the demo. This is take the picture Python script. You can see on the left hand side is the one that's selected. So this has got the facial recognition function, which I'll call later, and this is just storing the classifier. So that's how it detects. So it's the frontal face detection that I'm using. The ST button, just puts a button on there, and it says take a picture. And then once you click the button, this code here will run. So anything below there. So ST right changes the description, or the text, should I say, to say that something's been processed, just like they use an over that something's happening, whoever that may be. The next thing is to take a capture, and then take a still-in image, and then it's going to do a bunch of other checks in there. So the first thing it's going to do is write the image away to image file. It's going to display the image on the line above. That display displays it without doing any sort of configuration. So it starts off as a BGR, and then this function here changes it to RBG, and then saves it into this format here, or this variable. This function does the same thing, apart from changes it to grey, and stores it in the image.grey. And then we display a box, or display the image, and some text in that one, so it displays the full RBG, and then we display another image below it, which is going to be grey, and it's going to be grayscale. The next one is the face detection algorithm. So it's going to run the facial detection, which is that function up here. And it's going to run through that code, and then it's going to return a rectangle where my face is, or where it thinks my face is in the image. And then it's going to write that information to screen. And that's it. So you can see this is the take the picture app that I created through Streamlit. So you can see at the top left, it's got buttons that says take the picture. So what I'm going to do is I'm going to sit down, and this time I've VNC'd into it, just so I can position myself to take the picture while I'm looking at the camera. So I've just hovered the mouse over the cursor. So you could do the same thing by touching it. I'm just going to position myself so you can see my face, and then I'm going to click the button, and it's taking a picture. So you can see this is the raw image. So it's displaying it, but it's displaying it in a slightly different colours. It's something to do with RGB or BRG. It displays it the wrong way, a different way to the library was expecting, so it's slightly different. So then I've done a conversion and displayed it in the correct colouring scheme, grayscale, and then I've done face detection, and then I've just put some stuff at the bottom for the data, and that's it. Alright, this is the OpenCV face detection video. So this one I've selected on the left hand side. Quite similar to the take a picture, but it's just going to be continuously updating the video or the screen with the latest image. So it's very, very, very similar. So you've got face detection function there. You're recording from the video, recording from 0. We've got this option here, which tells you how many images it's going to take per second, or frames per second, and then we're going to loop through here, and it's going to take a read or a still image, and it's going to store an image. The success tells you, I think it's a boolean, tells you whether it's true or not. If it's not true, it failed for whatever reason, it's going to break, and then it's just going to continue that loop. The face detection is going to detect whether there's a face in that image, And then the second one is going to be a displaying that image on screen using the image holder, which was raised here. And it's going to select it as a BGR, so it's not going to do any conversion to it. And that's it. This is the OpenTV streaming video, so I'm just going to press the start button now. Should be looking at me any second and drawing a box around me.